Hi, everyone. Our next slide deck, you'll see it here called The Way of the Program, will give just a little bit more information about Python, about computer programming in general, and have us execute a few more lines of code in idle. Outline, take a look at the taxonomy or way to think about computer languages. What is a program? Give a question mark right there. Take a quick look at the software development cycle, where programming fits into the software development cycle, and touch on debugging. What are the different types of errors we encounter? So I mentioned in the earlier deck that is what's called a high-level language. High-level languages being those that are more people-oriented, closer to what we might think of as written or spoken or understandable English. Other examples of these might be C Sharp or maybe Java, Python, JavaScript, kind of classic examples of very high level. Kind of low level, on the other hand, these are machine code, kind of making things easy for the or making things possible for the actual hardware to do computing. So these are not going to be understandable by you if you saw that. Code would need to be interpreted and compiled in order to be executed. Um, Python code will need to be interpreted and compiled in order to be executed, but it is at least readable. And if you see kind of C sharp, I guess, these are examples of maybe intermediate level. And ways to think about that, diagram right here. High-level languages, easy for humans to understand, concise code. So you'll see typically fewer lines, fewer characters and tokens in the code. Something that's called object function oriented. And we'll talk about different data types, how variables correspond to different objects in our code. High-level languages are typically applied to manage system resources, and they have a lot of users because they're relatively more accessible. Low-level languages, these being kind of machine languages interfacing with hardware, these don't manage system resources. They directly manage the system memory here. Much faster, harder to write by people, therefore smaller communities. Just a little bit of a comparison. So in the last session, we wrote our first line of code, printing the string hello world. In C++, that same code, or the code to accomplish the same thing, printing hello world, quite a bit longer, includes tokens that, to be quite honest, I don't understand. If you were kind of able to write C++ code, if that's what you do, um, it becomes doable, I guess, more feasible. But on the other hand, it's still more lines, more characters, more things to keep track of. Similarly with Java. Python, a high-level language, it is interpreted in order to actually result in computations. It's object-oriented, so defines classes of objects and discrete objects that are acted upon by different functions and methods, transformed. The standard library, kind of pre-written code that you can call, is large. So kind of right out of the box, so to speak, you can do a lot of things with Python. And further beyond what just comes with the basic Python install, you're able to add other useful modules, some of which come with the install but aren't imported by default, such as math, but also tools having to do with data science, NumPy, SciPy. Right here. Asking the question here, what is a program? Program is a sequence of instructions, here we'll call them statements, that specify how to perform a computation. You can think of this as a recipe. You set everything up, you get all your ingredients, you read about the processes maybe for preparing the batter or I don't know, the toppings. And then when you have all that knowledge and everything's kind of clearly outlined and accessible, you can carry out the instructions in order. Basic elements of a programming language. Those kind of inputs here, data that comes from a keyboard entered at a prompt or from a file. Outputs here is kind of anything that's generated from the code, displaying data on a screen, could be sending data to a file or database. Math and logical functions, so the ability to perform basic math, logical operations. These things can be plus, minus, evaluating whether a statement is true or false. A sequence of statements, so kind of what way is the code read. Conditional execution, these are checks for certain conditions. Is the condition true or is it false? And if true, certain statements would be executed. If false, those statements are not executed. And then finally, repetition, the task of performing an action repeatedly, usually with some variation. So this could be performing the same kind of transformation to 1,000 different inputs. So here the input is the variation. Repetition is really important for any kind of programming or computer operations, just by virtue of what the computer is good at. It's very good at doing mathematical operations, evaluating the truth or false of these conditions, and then performing those over and over again. So this is kind of the benefit of computation and the hallmarks of programming languages. So here on this next slide, just kind of a quick bit of code that I'll talk us through. We have two functions, one called print colors, one called print file names. And we know these are functions because of this def token in front of it. And now on a subsequent line and one tab indented, a variable named colors is defined as a bracketed list of the strings red, green, and blue. On the next line, within the function print colors, a new variable I is assigned a value of 0, an integer. The next line introduces a conditional statement. While this condition is true, and initially it is, what gets printed? The member of the colors list equal to the value of I. So the first value to be printed is red, and then we see what looks like a mathematical statement. Actually, a single equal sign is just assigning a value on the right to the variable on the left. Mathematically, that I equals I plus 1 doesn't quite make sense. And there's no I for which that's true in kind of an algebraic sense. But what it does is it says, well, the new value of I is going to be equal to the old value of I plus 1. Kind of take what's on the right, assign it to the variable on the left. So I becomes 1. 1 is still less than 3. So the number 1 member of colors, green, is going to be printed. Then I increases to 2. And blue will be printed. I is increased to 3. And this condition is no longer true. So we exit out of the loop of conditional execution. Another print file names. This function operates exactly like print colors, except the variable is called file names. And instead of red, green, and blue, we have different shape files. You can see LND 1990.shp, 2000, 2010. But we still have the same while loop structure with an incrementing I variable, printing out the file name. And then finally, these functions that have been defined above are called. And when you call a function, that means it executes. So you aren't expected to know what every kind of structure in this code means right now. Just something that I talked through to give the example of math, of conditions, of repetition. And it is something that you'll know exactly how it works in just a couple weeks. Moving on to the software development cycle. So here you can think of the cycle as something, it iterates, it happens over and over, but it begins with the discussion of requirements. What is needed? What is desired? What's the goal here? A path toward meeting those requirements, attaining those goals is designed, and in the process of implementation, programming comes in. This is prior to verifying, okay, did the implementation work? Was it effective? Can we keep it up, the maintenance? And within that programming block here, you can think of cycles or to that programming task itself. So starting with algorithm design, algorithm being a way to do something, that involves coding, involves interpretation of the code and execution, possibly drawing on libraries or code that has already been written by other people or by you for another reason in the past, assessing results, and possibly debugging, because it is not too common. It's basically impossible to write code that does what you want it to the first time. What is debugging? We call errors in your program are called bugs. Process of resolving the errors, so fixing the errors. It's called debugging. We'll just quickly touch on the three types of errors. These are called syntax errors, runtime errors, and semantic errors. Syntax errors prevent the program from running because of some sort of mistyped or misspecified error in your code. So if you open a parentheses, but you don't close one, that would be a syntax error, and it would prevent the program from even running. Runtime errors occur when the program does run, but there's at some point in running encounters an error that it doesn't know what to do with. So this could be in some sort of a mathematical process. You have a denominator in a fraction equal to 0. So that's undefined. Program doesn't know what to do with that. And so it just stops and tells you, okay, you have a runtime error. Look in line 50 and fix it. Semantic errors, finally, are tricky because the program as written runs smoothly. You don't get any kind of message saying that the program couldn't run in the first place or it encountered a problem while running. Runs just fine, but the result is not what you expected. So think of it as kind of a logical error. You wanted to add two numbers, but in reality, you typed a minus sign. You just hit the wrong key. And Python recognizes both plus and minus signs, so it didn't throw a syntax error. It gave you kind of the difference of two numbers instead of their sum. And so you have to be on guard against semantic errors. And so you have to think about what kind of an output you'd expect. And when you get an output that's different from what you'd expect, it might be, you just had it figured wrong, but it could more likely be a semantic error. So you need to go find why, where that occurred and fix it. We mentioned development environments yesterday. So these are the software applications that allow you to write and execute Python code. The one we opened up is called IDLE, Integrated Development Environment for Python. Others include Python Win, PyCharm, PyScripter, uh, VS Code put out by Microsoft. IDLE is very simple. It's kind of bare bones, straightforward. So we'll take a look at that to write our next code. This is kind of a little outdated version of Windows, but you can find IDLE right in the Start menu here. So here I am on the virtual desktop. I just start, well, if I don't do typos, I get IDLE. We can open that up. There we go. So it's the Python shell. And so the other day we did the print function, print out a statement, a string right there, print. We can also assign values. So in this slide, there's slide 18, we're going to produce a script. So a script is just a code that's saved in its own file. So the instructions here, start IDLE. From IDLE, open a new script window. So the File menu, go to New File. Type the following 4 lines, and then save as that file. And here's the suggested name, and then a required extension, a .py for a Python script file. Finally, in that new file, you can hit the F5 key, run module, and the result will be seen in the shell. So I'm going to go here, go to File, New File, and it just opens up a text editor, really, untitled. X equals 2, y equals 3. It doesn't matter if you have that space or not. Maybe it looks neater, but it's not required. C equals x plus y, print z. And you can go to run, and if you try to run it, it says source must be saved, okay. So here, try to find someplace shared, chapter 01, example 01. And then the default extension here is .py. Now we can see the name and the extension up in the file header. And we get the result, just the integer 5, printed out in the shell. So if I change that 3 to a 6, and I save it, so we'll go File, Save, Run, Module. Look back over here in the shell, and we got an 8 now. So that's some basic arithmetic. We've got 1, 2, 3 variables defined. We assign them values, and then we call the print function to print the sum.